All right, everyone. Thank you so much for joining us for NOFA New Jersey's quarterly book club. Very excited to have Michelle Avis here today, who's worked all around the globe, I imagine, right at this point, installing permaculture design and rainwater harvesting systems to help really utilize our natural resources in a much smarter and much more conservation-minded way. Michelle, do you want to go ahead and give a brief intro, and then we can dig into some of these awesome parts of your book, Essential Rainwater Harvesting?
Great, yeah. So my background is actually in mechanical engineering. I graduated almost 20 years ago now and started off actually in the oil and gas industry because the university that I went to is really much in an oil and gas type city. So that was kind of the natural progression. Did that for 5 years. And although I really enjoyed the work, there was something I just didn't feel super passionate about the kind of stuff I was doing. So my husband was the same. He's also an engineer. And at one point we decided to quit our jobs and just go traveling. And we were really, really interested in sustainability and sustainable solutions. So this is back in 2007. And traveled the world, discovered permaculture. We actually started off at a renewable energy institute in Denmark, learning all about renewable energy and low energy buildings. Became fascinated and decided we were going to retool our toolbox and kind of apply our engineering background to making the world a better place. And came back to Canada, and around 2010 started up a permaculture design company, so where we design and educate on sustainable design. How could we build things better? How could we do things better? And then about 3 or 4 years later, maybe it was like 2014, 2015, we actually were approached by New Society publishers and they said, hey, you guys should write a book. You guys have been YouTubing, you've been doing a lot of stuff. We were doing a retrofit project on this little urban house in Calgary, and we had done a full energy retrofit on it. We had torn out all the lawn and converted it to gardens. We built a greenhouse. We were capturing all the rainwater off the roof and putting it either into the gardens or capturing it for use. We had solar panels. Like, we went to the full 9 yards in terms of like a urban retrofit. So they said, you should write a book. And I toyed around with some of the topics that I was interested in. And rainwater was one that I thought, I think we could write a book on this. And just with that, agreed, started doing a ton of research on how to design rainwater harvesting systems. And I stumbled across what was really neat is I did what most people do is I went to codes and standards and what was already published out there in terms of how to put together a rainwater harvesting system. But then I also started reading the research and what did the research say on rainwater systems. And it's tough to find good research, actually. I had to go all the way to Australia, found a gentleman who's been arguably one of the few researchers in the area of rainwater harvesting. His name is Dr. Peter Coombs. He's been monitoring and researching rainwater systems for well over 20 years. And he's had multiple PhD students do some just fascinating experiments to try and understand how do they work and how should we design them based on this knowledge. And I asked him to do a book review for me as I was getting close to publishing this book I had written. So I sent him off my manuscript and he came back and he said, you know what, you should change this, this, and this. And I want you to read this research paper and you should read this research paper. And, and it just blew my mind because he kind of really introduced me to this idea that there's actually a ton of misinformation out there on rainwater harvesting, even in the published codes and standards, and that the research doesn't necessarily support some of the things that are being recommended. There's tons of myths around how rainwater harvesting systems should be designed that the science just does not support, doesn't align with. So I made as many revisions as I could based on his input before hitting the publication date. But I enjoyed working with him so much that Peter and I have continued to collaborate for the last 4 years. And we've been teaching courses on rainwater harvesting systems and how to design them based on science. So that's a little bit of a background. And I think we've also written one other book, my husband and I. It's a very painful thing to write a book. It's like having a child, I think.
Labor of love.
It's so painful, and then you get through labor, and then you forget how horrible it was, and then you do it again.
Well, at least you can forget
and we
your
wrote
books.
a second book, Building Your Permaculture Property. So now we have two, both with New Society.
So can you talk about, I just find it interesting that there could be misrepresentations about rainwater harvesting in the industry. What are some of the false information that's spread?
Oh man, there's so many myths. I think where I want to start with is what I would propose is I'll bring up an image, I'll bring up an illustration of a well-designed rainwater harvesting system, and I'll walk you guys through it.
Perfect.
And then what I'm sure will happen is you guys will start to ask me questions about, don't you need this? And don't you need this? And I heard that, you have to do this. And that's going to be a great way for me to bust a lot of myths around rainwater harvesting. So, and you guys are such a small group. I would love it if you turned your cameras on, because then I don't feel like I'm just talking to Devin. And one of the advantages about being a small group is I would definitely welcome you to, if as I'm going along, we can make this more conversational and more interesting, right? And I can feel less like one way. And you guys are welcome to use the little hand raise thing. And I'm really okay. We could open you up to asking me questions as well. But I hope at the end of this, we'll try and keep it to an hour. You'll have a good idea of how to design a really great rainwater harvesting system. And the thing is, it's actually really simple. The myths all revolve about having to do these things that you don't have to do. To design a rainwater harvesting system that's going to produce quality water is actually very simple, and you don't need a lot of components. So, okay, thanks. Nice to see you guys all. With that, let me open up my screen. So this is a little illustration. You guys can all see that of a roof harvested, and I'm going to differentiate harvesting rain off of a roof from harvesting, rain from maybe the pavement, right? And it's quite different. Can you guys think of why it would be really different design constraint when you're talking about collecting water from a roof versus collecting water from a ditch? Anyone want to throw it in the chat or shout it out? Why would that be different? And why would I start with saying this applies to roof harvested rainwater?
Gravity.
Gravity is one. Yeah, that's a good one. What else is really different from the rain that's going to hit your roof, from the rain that you might collect out of a
whether it's accumulated other things. So
how clean it is,
or dirt, or all kinds of things that you might have to then filter out versus straight from the sky.
So roof harvested rainwater is actually from just inherently, it's really quite clean, right? In fact, rain, you go out in the rain, it's like some of the best water. It's the best water you could possibly get, right? It's better than the city water that comes out of your tap, chlorinated. It's better for your plants. It really is high quality water to start with, compared to water you might grab out of a pond, or water you might grab out of a creek, or even water you might get out of the groundwater. So the starting place with rainwater is that it's actually really clean, really high quality water. And that's one of the big myths. That's a myth right there, right in of itself, where people would actually believe that rainwater is kind of dangerous right from the start. And that's totally not true. And you can think about it logically, of course not. We can go walk in the rain. Nobody gets worried about having rainwater on your skin. But you read some of these codes and standards, and I kid you not, they're like, do not put rainwater on your skin without running it through a UV system. It's crazy.
Can I ask a quick question about acid rain? Because I used to live in New York City, and I remember like years ago vaguely hearing comments about acid rain hurting buildings.
Yeah, it's
So
not
what
an
do you
issue.
say to that? Like, and when people bring up that kind of concern, what do you say to that?
Okay, so the natural pH of rainwater is 5.5. It's slightly acidic due to carbon dioxide that's naturally present in the air and that dissolves in the rainwater. So rainwater is naturally a little bit acidic. That's not a problem at all, right? And this is really different from acidity can, water can become super acidic due to pollutants. Like let's say you're living near some sort of a chemical plant that's got in an industrial area that's putting lots of chemicals into the air. Well, maybe, but 90% of people are not in that scenario. So no, there's no real concern around acid rain. And that, like, when was the last time you even heard about an acid rain event? It's been completely blown out.
Yeah.
No, there's no concern. No real concern. Yeah. Get that one all the time. Acid rain. So rain itself is really clean. It's your best source of water. I would drink my rainwater any day over my tap water that's coming from the city that's been treated, hands down. So then let me just walk you through what a well-designed system looks like if I was a piece of rain and landed on my own roof here. And notice that this is even an asphalt roof in this particular system. And that question gets asked a lot. I definitely don't love asphalt roofs for harvesting water that you're going to drink or use inside. Having said that, it's totally doable and you can still get good quality, drinking quality water off of an asphalt roof. I definitely prefer metal roofs, but it wouldn't necessarily stop me if I had a good design in place. Most people, in terms of using an asphalt roof for irrigating gardens, no issues. I wouldn't even hesitate to capture rain off of an asphalt roof to irrigate my garden. I'm not concerned. So it's really just that, is there anything in the asphalt that's going to end up in your drinking water that would be slightly concerned. And if it's an older roof that here's the interesting thing about and I'm jumping ahead a little bit. I got a lot to cover in an hour. The materials in your system have a far lesser impact on the water quality than people think they do. The biggest impact on the water quality, or the thing that most is going to improve your water quality, is the biofilm in the tank. And I'm going to get to that in a second. Okay. But the materials have a far lesser impact on your water quality than you might think. But anyways, I'm a drop of rain. I land on my roof and I'm going to go into my gutter here. In Canada, we call them eaves troughs. And then I'm going to come down the downspout. Now this is this little device here is kind of unique to cold climates, places where you freeze in the winter time. You have kind of freeze thaw cycles and you don't want water to a tank in the winter. So this is called a diversion valve. So you can just flip this flap. And so for part of the year, you can divert all your water just to landscape, right? Or if there's like some snow and kind of rainy snow. And then for the part of the year where you're actually using your rainwater, you just turn this flap and the rainwater goes this way. So arguably, almost the number 2 most important thing, because I've kind of told you already, the number 1 thing is this biofilm. But the number 2 most important thing in your system is this leaf diverter, this guy shown right here. And what this does is it's a screen at a 45-degree angle, and then there's another screen at a 90-degree angle. But any particulate that's coming off your roof, any leaves, primarily, any larger chunks of organic matter that might be carried with your with your rain, it's basically preventing that from getting into your tank, and mosquitoes as well, and bugs and critters and all that stuff. But it's basically this fine mesh screen. They're called Leaf Eaters is one of the brand names, and the Leaf Eater original, the cheap one, the very simplest model is the only one you need, probably about, you know, anywhere from $40 to $50, I think, and that's imported from Australia. So you absolutely want to include one of these, this screen. So the water hits this screen, any leaves and any bacteria usually attached to the leaves is kind of pushed off and flushed away. Then the water travels through a pipe, and the configuration can be slightly different. This one's just showing the water going over to this inlet on this tank. This inlet is also screened. This is, I'm going to show you another picture of what that looks like, but think of a tank, a screened inlet. The water is coming free falling out here, but it's going through another screen. And the second screen isn't so important. It's just that we need to have screened inlets and outlets on the tank. You really want to keep any kind of organic matter from getting in there and keeping bugs and critters out. That's really important. So that's the function of this, and in this configuration, what this manway is. So then your water falls into your tank. And another really popular myth is that once a year you should drain and chlorinate your tank. That is a complete myth. And in fact, if you do that, you're going to get worse water quality. And the reason for that is that your tank, a well-functioning water tank, operates like a bioreactor. And this is really fascinating research that comes out of Peter Coombs's group in Australia, where they discovered that over time, water quality in a tank would just improve all by itself. And they were trying to figure out, why can you just put water in a tank and over time will the quality improve all by itself? And what's happening is you've just got naturally occurring bacteria all around us, right? There's bacteria everywhere, on our skins, on the surfaces, that end up in these tanks, and they form really quickly. These communities of bacteria form within several hours, and they line the exterior walls, they line on the bottom of the tank, and they're hungry. They're really, really hungry, and they will eat bacteria. They will eat bacteria, they will eat heavy metals, they will eat all the things you don't want in your water. And if you follow the advice that's commonly out there to drain your tank and to chlorinate it, you actually kill these incredibly useful ecological services, like these communities of bacteria that are helping you out. You kind of think of it like your gut biome, right? There's been a lot more acknowledgement recently around, you know, we have all these, we as humans have all these communities of bacteria that help us and keep us healthy. Well, it's kind of the same thing, right? So you don't want to disturb your biofilm because it's doing you a huge service. It's cleaning your water, and it has the biggest impact on your water quality. What will happen is through sedimentation and flocculation and all these natural processes in your tank is you'll get some settling too, and you'll get, you know, we call it a sludge layer, which is kind of a horrible name because people tend to think of it like in a septic tank, this giant layer of sludge. It's not really like that, but there might be a sedimentation layer that forms at the bottom of your tank. And really all you have to do, and this layer doesn't grow infinitely. It kind of strikes a balance because the bacteria is eating it, right? More sediment's coming in, the bacteria is consuming the sludge layer. It really will never get above a couple inches as long as you have screens, making sure that you're not putting a lot of organic matter in your tank. Screens are super, super important. So then as long as you have your outlet, so this is where we're drawing water from the tank, we recommend that you keep that, you know, 4 inches above the bottom of the tank. You're never drawing water from this sludge layer. You're going to get very clean water when you draw that water from your tank. And then before I keep going this way, I'm going to move up to the overflow. All tanks need some sort of an overflow so that, you know, you've got water coming in, but you'll need a very large tank for it to never overflow. In fact, it's almost unrealistic. If you have small tanks and you've played around with them a little bit, you'll notice they're often overflowing more than they are not overflowing, especially in rain events. But you do need an overflow, and you'll want a screen, that's what's shown right here, on your overflow as well. And I see Jacqueline, yeah, I'm happy to stop for you.
Yeah, that's really interesting about the biofilm inside, and that seems to develop as the water comes in. When you were talking about materials not so important, does, I'm just thinking about like PVC plastic and water bottles and people talking about that and finding alternatives and being concerned. Do you need to have the interior of the container be a particular material? Are we trying to avoid certain materials? Or is that what you mean, that it doesn't really matter because once you have the water come in, that biofilm starts to become created and will help protect you no matter what the material is?
So it's not that materials have no impact, they just have a far lesser impact than you might think. So for sure, if you're using your water for indoor drinking uses, stay away from lead, anything lead, right? Lead flat, and that could be lead flashing, which is commonly used on houses, on your roof, right? And you'll probably want to buy a potable grade tank, probably. Or for instance, what I see people do is they use those IBC totes. Do you guys know those square totes with the cages on them? Sometimes you can get those free. They're about, they're 1,000 liters. So that's what, 200, no, is it 4 times 1,000 liters? How many gallons is it? 4,000 gallons? It's the other way, right? Those IBC totes are great and they work really well, but often you get them surplus, like people pick them up because some factory is getting rid of them. I would stay away from IBC totes that were used in, say, like with brake fluid in them, right? Because those do get thrown away. I would go to the ketchup manufacturing facility or the mayonnaise facility and try and get the IBC totes that were full of olive oil or some sort of a food grade product, right? So it's not that you should, like, you still, stay away from heavy metals for sure. But beyond that, the materials are more forgiving than you might think. The other thing is I don't like tanks that don't breathe. So there are some bladder tanks that you can get. They're popular for people trying to retrofit their homes and trying to fit a tank maybe under a deck or fit a tank in their basement, and think of like a waterbed, right? They're bladders. Those can't breathe, so they don't get those biofilm communities, and the water quality in those are horrible. But that's equal. That's really almost because the tanks can't breathe and not so much the materials themselves.
And is the breathing from the screen on top?
Yeah, it breathes, right? Yeah, there's air. And when I say breathe, it's just open to, it's kind of open to atmosphere. It can have an exchange with the air. Yeah. Which is 90% of your tanks. Really, the only example of a non-breathing tank is those bladder style tanks. So I don't like those at all for quality water. But you can use concrete tanks if you're going really big, really common. These are often made from like plastic tanks are pretty lightweight and inexpensive. The ones that your agricultural supply sells are really good. Or even the rain barrels. The rain barrels are small. They're kind of like your gateway drug into rainwater harvesting. You start with a rain barrel and then you realize it's always overflowing. I'm not capturing very much water. But a great size while we're on there for an urban property, if you're looking to supplement your indoor and outdoor water with rainwater, 5,000 liters is a really good number. So what is that? 5,000 liter. 5,000 liter. It's divided by 4, isn't it? Yeah, 1,000 gallons is a really, if you're like serious about rainwater and you want to like supplement, that's a reasonable size to aim for. Now, of course, it depends on your climate conditions and how much rain you get, but that kind of helps you contextualize what I think is a really good urban rainwater tank. Anything smaller than that, you're kind of just playing around with rainwater. So that in a nutshell is your tank. And of course there's more to it, but their tank is phenomenal. It does so much good work for you. So then I'm continuing, I'm a little particle of water, kind of I've swam around in here a little bit, and now the pump turns on. And this is an indoor system, which I know is not as common in North America. It's quite common in Australia. There's like 6 million people who have dual systems or use rainwater for indoor use. I'd like to see this become more common in North America, but it's not. But you could, if you're not at all interested in using rain in your home and you want to just think about this for irrigating gardens, you know, same thing, you might have a pump. Or if you're storing water at elevation, you could probably also just use gravity water. And just based on having a filter, a leaf diverter, and screens on the inlet and outlets, and biofilm in your tank, I wouldn't have any, I wouldn't even blink about irrigating my garden with that water. You don't need anything other, you don't need any other gadgets or filters or UV or chlorine. The water is safe to use for garden irrigation. I feel very comfortable saying that based on the research. But let's say you did have a pump. The water would travel through, you know, it would kick on. The pump would say, oh, there's demand for water. It would kick on. It would come through this way. And all pumps have an integrated screen. So this is called a Y strainer. It's just here, but all pumps have a screen to protect the pump. So the first thing would happen is I would go through another 30 micron filter right here. And then I would, so that would remove any other, if there was something else in the water, another barrier preventing or cleaning that water up. And then I would travel through this pump. And now something really interesting when water goes through a pump, bacteria, specifically pathogenic bacteria or harmful bacteria, are really fragile and they hate changes in pressure. So if there was something on your roof, if there was some sort of pathogen from something that was possibly harmful to humans, right? If, and if that didn't get destroyed by sun, because pathogens are very fragile, and if it managed to make it into your downspout, and if it didn't if it wasn't already attached to a leaf and get de-energized or get, you know, flushed through here, not flushed through, but not picked up into the water, and if it didn't get eaten by the biofilm in the tank, and if it didn't get caught through this 30 micron filter, it would then be subjected to this change in pressure, right? Which is another kind of barrier, reducing the risk of something being in that water that could possibly make you sick or you would be concerned about, and travel onwards, right? So another kind of element in the system. So Peter and I like to talk about your rainwater harvesting system is a whole bunch of things and components, one after another, that kind of function together as a system. And all of these different things, you know, work together to deliver quality water at the end use spot. So coming through this pump, what happens next? You go through this pump. Oh, this is a special kind of valve that is, you would only really need to know much about if you were trying to have a dual supply system. So this is really neat. This would be municipal water coming up from underground. There's your water meter, right? So this valve allows you to have dual supply, allows you to have water come from mains when the tank is empty, and then allows you to put water from your rainwater tank when there is water in the tank. So that's what this is called. It's called a dual supply valve. And they're a little bit specialized valves, but they allow for these dual systems to operate really, really well. But the water would travel up this way. and then if it was hot water, if there was a hot water demand, and that's what's shown as red in here, the water would travel through the hot water tank. And once again, pathogenic bacteria in particular, and all bacteria, hate changes in temperature, even more than they hate changes in pressure. So research has shown that doesn't matter if they're instantaneous hot water heaters or if they're just more typical hot water heaters. What are they? Non-instantaneous hot water heaters. This device that almost all homes have will, again, if there was something in your water, greatly reduce the possibility of, or I should say, increase your water quality is actually more correct. So once again, your water quality is increased because of your hot water heater. And so that's why it's not, once you have hot water, you can say if hot water is going to the shower, you don't need any other treatment. You basically, after you've gone through all of these interventions, 1, 2, 3, 4, 5, 6 being your hot water tank, that water in terms of showering or maybe washing, hand washing, or the hot water on your kitchen tap would be sufficient for its end use. If it's cold water and it's going to the drinking water tap, we recommend one last intervention, and that would be like an under sink filter, usually around 2 to 5 micron. Let's say 2 micron filter, carbon filter under the tap. And so there's one last intervention that, and in fact, I recommend these carbon filters even if you're on city municipal water. I think they're really excellent. Anytime you're drinking, or if you're on a well I think this is a really good filter to have, no matter what water source you're drinking from. But that in a nutshell is actually an incredibly well-designed rainwater harvesting system. And depending on your knowledge of what's commonly designed out there, what you see out there, you may or may not notice that it has relatively few components compared to what many codes and standards and what many people are currently putting in their rainwater harvesting systems. So you'll see lots more devices out there, such as something called a first flush diverter, or there's something, there tends to be a lot of components in the house, UV sterilization, lots of filters, or chlorination. And yeah, the research has shown that none of that is actually required. And in fact, making the systems more complex and making them use more energy actually has the reverse intended effect, is that these systems are actually more difficult to maintain, and they're less sustainable, especially if they're using a lot more energy. So that, in a nutshell, that was a lot that I kind of tried to cover, is what a well-designed rainwater harvesting system for indoor use could look like. Yeah. Jacqueline, I see your hand.
Sorry, thank you. I just noticed, is this like a little concrete base under the water tank?
Yeah.
And is
so
that, yeah.
Well, it's not a concrete base. It is, they've got several options, but water is heavy, right? Water is really heavy. And especially the size of tank that's shown there, that would be a tank, as tall as me, which isn't that tall, but let's say 5 feet and a few inches tall. It's going to weigh a ton or more, right? So just like anything, anytime you're putting weight on soil, you have to build a proper foundation, right? And there's several ways to do that. There's, you could do a concrete pad. I find that a little expensive. I like this, it's basically a compacted gravel pad where you strip the topsoil, because that's spongy, the garden soil, the topsoil, the high carbon stuff, which is great for growing food in, that's really spongy. You put anything heavy on there and within a year, your tank's going to be kind of tilting. Right? So you got to strip off that nice spongy topsoil. And plus you want to put that in your garden. You don't want to just squish it under your tank. And then you got to build your base up from the subsoils, and usually using some sort of compacting gravel. So it's pretty typical. This is stuff that any tank installer, if you were to buy the tank from your tank manufacturer, they're going to give you good instructions on how to build a solid base for your tank. But it is important to build a good base for your tank. And that's why it's shown on this illustration. I think in in where we use this in the course, you know, we visually wanted to show it because it is important to point that out. So I'm glad you saw that. And another thing I'll say too that this diagram shows is how important, you know, I'm talking about roof harvested rainwater, but really there's so many opportunities just to do better with our stormwater. So, or the overflows from the rain tank. So the illustration here shows that the overflow and this pipe both go into like a mulched basin, right? Because that's another place, another area. We just do so poorly. You just walk around in your neighborhood or wherever and look at all the rain that's just being almost pushed to sink, right? It's coming from the sky and everybody's just trying to get rid of it as quickly as possible.
Could I'm Bob.
Hi, Bob.
I wanted to add a comment. This system that you're describing is more or less the system that was installed at the new chemistry building at Princeton University. I don't know whether you're familiar with that or not, but if anyone would like to visit or see what such a system looks like, it is used entirely for toilets, and I think maybe urinals too, but I'm not sure. I mean, they may be waterless urinals, but it goes through pretty extensive treatment, including UV, and then dye is added, so there's less chance of mixing up the two systems. And my guess is that more precaution is being used for liability purposes. This is a public building. There are students. Some of the parents of the students donate millions of dollars to Princeton, and they don't want to see their kids get sick by some rainwater system. I guess that's what the thinking is. But in any case, it has a first flush diverter, everything that you're showing there, but also a disinfection step.
Yeah, I'll be honest, I'm not a fan of disinfection steps. I realize that disinfection steps are being heavily promoted by the codes and standards, but the science just doesn't show that they're needed. And in fact, tend to cause, especially for home systems, where arguably, you know, in commercial systems, you know, especially for roof harvested rainwater, there, you know, especially if you're just flushing toilets with it. So there's just some insanity going on. And my husband worked for a research institute in Calgary that was similar to, you know, what you described, put in a kind of a model rainwater harvesting system for flushing toilets. And then they went around and put signs on all the toilets and urinals and said, do not drink this water because it's rainwater, right? And like, I have a picture of this sign, like the insanity, you know, the pathogens, we don't go, like, what's going to make you sick in the toilet is not the rainwater, right? But we don't go around in public institutions and put do not drink this water on toilets all over the place, right? So there's this interesting, Peter and I are working really hard to try and change some of the conversation around rainwater in North America, because we see it going in a direction that we don't think it should, which is that starting from a place that rainwater is dangerous, right? That roof harvested rainwater is dangerous and has really bad things in it, because it doesn't. And what happens with these UV systems is, you know, they're not really going to work very well anyways if you're not, if you don't have the right kind of filters on your tank, and if you're not taking good care of your system, and if you're not doing good design from the onset, which really means lots of screens on your tank, you're going to end up coating those UV lights, and the energy required on those UV systems, it's insane, right? So suddenly you're doing the right thing to harvest and use rainwater, but you're expending copious amounts of energy with these UV systems, which are actually just not required, especially for flushing toilets. Like, that is just insane. They're not even sending them to the drinking tap. They're just trying to flush toilets with UV water. I think it's ridiculous. And what's really interesting is that in Australia, where they have a culture of rainwater harvesting, and there's, I think 6 million people who use it in their house, and maybe 10 million who use it for some other use. They've done, and this is without end of line treatment. So almost virtually none of these systems in Australia have UV or chlorination, which is being touted here in North America as you must do this, you must do this. And there's been large scale health studies done where they've studied the overall health of rainwater drinkers versus people on the municipal water systems. And they've discovered that rainwater drinkers actually have slightly better health outcomes and slightly better health, right? And these are large. There's been 2 because they didn't believe the first one. So then they commissioned a second one. And so that kind of data, that kind of real world data counts for something. It just shows that, if rainwater was dangerous, you would see it in these 6 million people who are exclusively relying on rainwater versus, and if municipal water was better for you, was that much healthier for you, right? So what's really happened is you've got, I think, as we're trying to get, rainwater harvesting more commonplace, there's lots of liability concerns. But also what happens on these codes and standard committees is you get special interest groups that represent products. They represent the UV systems and they represent these fancy things. They influence the codes and standards in directions that I just don't think the science really supports, because they kind of want to sell more stuff. So, that's where I'm really big into the education on what does the research show in terms of how to deliver quality water in rainwater systems. Yeah.
Do you have like a handbook or something, or a worksheet that, I know you've written your book, but like something that to help use in conversations with city council or something like that?
So what I'm going to recommend, if you're really interested in kind of learning more about all of this stuff, I'm going to post it in the chat. I have a comprehensive, Peter and I teach a comprehensive course. It's a 4-month course on how to be, rainwater harvesting. But we also offer, there's a free taste test that pulls out, I think, 8 of the most important lessons from the course. And it's a fantastic little taste test. It goes through all the science behind the biofilms, behind the research and the health studies in Australia, the system, the anatomy of rainwater harvesting system as I presented. And it's both Peter and I talking about all these things. So I posted it in the chat, and you're absolutely welcome to register for that. You'll get the course in your email inbox, and there's some videos that go with it. So that's a really great place. And there's tons of stuff on our YouTube channel too, Peter. If you search out the Verge Permaculture YouTube channel, Peter and I have done quite a bit of stuff on there regarding rainwater harvesting. And he's brilliant because he's a microbiologist and he's an engineer and he's been studying rainwater for 20 years. So there's really just not a single question that he can't answer with science. So I've really enjoyed him being my mentor and me being his mentee, and just learning all this.
Can I ask a quick question here? So I mentioned I have the rain barrel. I don't have much money to spend on any kind of fancy setups. Let's say that I just start collecting into my rain barrel via a screen. It's open to the air. I raise it up a little bit. Maybe I have it on a couple cinders, a real, backdoor kind of job there. Is there any danger? What's the worst case scenario that happens if I collect in a very rudimentary fashion like that? Maybe I put a little spout at the bottom. What are some of the pitfalls there? Because I imagine there's a handful of folks in the same situation.
Are you gonna you're gonna screen it? You're gonna do like a fine mesh screen
Mhm.
on inlets and outlets? Oh man, and how big of a tank?
55-gallon drum, just a,
Yeah, I mean, I can't really think of any pitfalls
okay.
you would run into. The biggest thing is people don't, you know, if you don't put screens on them and you start to get organic matter in your tank, that organic matter is going to do what organic matter does, which is to break down and decompose. And it's going to get stinky, or if it's open, you could, you know, get mosquitoes, you know, hatching in there. But that's why just with screens, no issues. No issues.
And let's say somebody does install a system like that and finds they've got the slime or whatever that nasty is that builds up after some time. What's the ideal way to clean it out? Anything you would
Yeah,
suggest?
but so the slime, it's only going to build up if you let it in there, right?
Mhm.
So, you know, it's a sign that you're letting stuff in your tank somehow. Like,
Gotcha.
what, is there a hole in your screen? Where is that organic material coming from? Because rainwater is low nutrient. There's no nutrient in rainwater, right? So don't let it in your tank, and you won't get the slime. You won't get slime buildup. And then if you do have concern about the quality of your water, so there's a really good rule. If it's clear and it smells okay, it's probably fine to drink. If it's roof harvested rainwater and you've got all the interventions that I talked about, if it's clear and it smells okay, it's a very, very high probability it's fine to drink. If it's not clear and it doesn't smell good, well, then drain your tank and start over. Figure out what went wrong. Yeah.
Can you repeat again because I'm wondering about, like, with mosquitoes, the mesh screen, what size you use on the inlet of the tank?
Oh, is it like 2 mil? It's pretty fine screen. If you want to keep the mosquitoes out, 2 millimeter, what would that be in inches? 2 millimeter screen, you're fine stuff. Here, I'm going to show you, I'm going to pull up a leaf eater, what a neat leaf eater looks like. Screen share it. Leaf eater images.
And then Michelle, in a moment, if you think it would be nice to see that real world application, crops could hop on and talk about their.
Yeah, sure. If they'd like to show it to me, I'm happy to see it.
Cool.
Okay, guys. So this one here, well, this has got this one's a neat, this particular brand, the Leaf Eater Original, is one of the best. And Peter, you know, they did trials on all of them, which the coolest thing about it is it's also the cheapest one because it's super simple. You can get really fancy looking ones, but this one performed the best. And it's got the larger screen at the 45 degree that really picks off the, you know, the leaf and the bigger litter. And then it's got a horizontal screen. Can you see it? With the black trim? That's, I believe, 2 mil. What would that be in inches? I'd have to look that up. But pretty fine.
Almost 0.1 inches.
Yeah. Thank you. All right. Yeah, if Crops wants to show what they're up to, that'd be great.
Yeah, Eric, if you'd like to hop on, just to preface, I went down to visit Crops and I was blown away by their rainwater catchment systems, and they've got some really awesome plans. So I figured this would be a great time to share. If anybody wants to see, I'll put the link to Crops website in the chat as well.
Awesome. Well, thanks so much for inviting me. I'm a little nervous. This isn't my forte, being on the computer and presenting. I'm more in the garden. So Crops is a nonprofit it started as a farmer's market in 2016, but I'm having trouble sharing my screen. Give me 1 second. So we started in 2016 with farmers markets and expanded from there to do community gardens, educational programming, and just creating a lot of partnerships. Our acronym stands for Communities Revolutionizing Open Public Spaces. So we really just try to get people together and try to make the connections where they can be made. So this rainwater catchment system wasn't solely us. We recruited the help of Porta. Actually, they came to us because they were looking for a mission project. I'm going to go through. So Sarah and Connor, both from Michigan, they created this program where they went to Haiti regularly and they would create these rainwater catchment systems. So they were primarily for drinking purposes, but kind of expanded to agricultural purposes from there. So when the pandemic hit, they weren't able to go to Haiti and they needed a service project. So they reached out to us and were like, awesome, yeah, we'll definitely take a rainwater catchment system. So I didn't know anything about this. They came with all the knowledge, but you can see, just like Michelle mentioned, like they taught us about the foundational system, and we were lucky that our site was pretty flat. So they did the gravel, they sourced all the materials. This group actually came completely separate from them, but they're also from Michigan, which was kind of a coincidence. But this was a youth group from Indiana, and they just did incredible work. You can see them, and this is all teenage kids. So like they're using power tools, and I'm just standing aside, literally watching them. I didn't build any of this. They did this all themselves. But the rainwater catchment system. So we had a 2-tank system. We wanted to be able to let people of the community come and service, water bottles themselves. Pleasantville, New Jersey is an NJDEP registered food desert. So any access to like vegetables or produce or even drinking water is an awesome resource. So the bottom tank was our holding tank. And you can see in this view right here, you can see the spout that brings it to the pump. And this is them building the filtration system. So again, I didn't know anything about it, but now hearing what Michelle has mentioned, we might revise the thing. We might revise the whole system, but they did put a filtration system in it. 3 different levels of filtration, starting from large to small particles. I'm not sure exactly the micron size on it, but I do know that it gets pretty small. And they gave a hole to also do a UV system, but we haven't been able to do that. But now after watching this and, reading the book, it's definitely up for debate how we're going to move forward with that. This is the group working on the projects. Sarah and Connor. I already showed you that.
Yeah, I want to interrupt you for 1 second, Erica. I'm also from crops. I'm trying to hang on. I have a little one that I'm putting to bed, but I just wanted to say that it was so interesting to hear what you had to say, Michelle, because one of our goals, learning about this rainwater catchment system and using it to both water our garden, and then also having the filtered rainwater coming out of the sink, out of the front of it to wash vegetables and everything. I had no idea that you could just drink rainwater right from just rain. I didn't know that. And I think one of our goals with this, learning the rainwater catchment system and having it in underserved communities is to be able to offer a spot where someone could just fill up a water bottle, particularly in a place like in Atlantic City, which we also have community gardens in, and there is a very large homeless population. That's a huge resource. It would be interesting, to hear your opinion too about as far as the liability stuff and whether, we could work with a municipality and or a state to get approved for something like that if we were not committed to doing a filtration system.
And I'll say I can speak to the science. I can't always speak to the local regulations, right? And I can tell you what I would feel comfortable designing as an engineer, based on lots of systems. But sometimes your hands could be tied as well in terms of what the regulators tell you have to do. And then the only way to get around that is to get informed and to become a rainwater harvester, and so that you can feel comfortable saying, no, I designed this system, I have the knowledge, and I know it'll work, right? But what happens when you don't know, when you don't have the knowledge and you don't feel confident, that's when the regulators are going to say you have to design to a code or standard. And those codes and standards make you put in a UV system, which kind of makes sense, I suppose, right? But
I guess on technicality, it
sure.
does make sense,
Yeah.
but it's also like, that's a big component of crops, is like empowering you to like know for yourself, like what you feel safe doing, and like being able to kind of advocate for that, because it, like you said, like the laws and the local like regulations don't speak to the science of it. And like you said, like rainwater is perfectly safe to drink. Like if it's,
I heard that I didn't catch her name, but whoever was also from crops talking about how like, and that's the insanity. Like we kind of think that rainwater is bad, but it's like, it's not. It's so clean, and it's better. It's better than the city water before you do anything to it, right? But we kind of have this perverse idea that it's dangerous, so much so that like, oh, don't let it touch your skin, right? Yeah, no,
So
it's really
weird.
clean. Yeah, sorry, keep going with your presentation.
yeah, no worries.
And I think the filtration is probably good. It probably is just several stages of filtration, which I think is great, where I'm very hesitant around UV systems. So I think they're complicated and expensive, and they're going to take a lot of power. So if there's a way you guys could convince yourself that you could meet the safety and the quality standards you want without UV, I would definitely encourage you to go that route. Yeah.
I mean, we've been using it without the UV. Oh, sorry. Go ahead, Lisa.
Oh, no, I was just going to say exactly what you were going to say. That's the one filter that we're missing, is the UV filter.
Yeah, you don't want that one. You don't want it.
There we go then. So we're not missing
Perfect.
anything here.
I don't think you want it. Yeah.
So this was our finished system. On the left, you can see the little spout that you can use to wash your hands. So the gutter up here actually has what Michelle was mentioning, the leaf cover on top of it, and it goes down into a first flush device, like you mentioned in the book, which is really cool to read in the book because he explained it, but I didn't know like the technicalities of it. So we did have one of those and the exit pipe right there to clean it out, which we do maintenance on that pretty regularly. So it'll go down this pipe down here, hang out in the bottom tank right there. And then once this fills up, we'll pump it through that filtration system with a pump that we have. And it hangs out in this upper tank. So this tank will feed the sink, which you can get water out of. And the rainwater tank will feed our hose, which supplies all of our garden right here. It's pretty cool. It was the coolest thing, I think, that I learned from them. And then just having like the art part of it was cool. You know, you build something that's like effective and useful, but then you also like include community and like, you know, include an art aspect and joy. And it was just really awesome to have the whole, this is Paige's daughter with some more volunteers. And then they came to our Atlantic City Gardens, which Lisa mentioned, we're trying to get a rainwater catchment system so people can drink on demand and yeah, feel good about it. Have their vegetables, wash their vegetables, get some water, the full system. And that's it. This was the whole group. I think Connor is not in this picture, but yeah, this was the whole group that helped us build it, minus Connor. And yeah, it was a good time. And just thanks for inviting us. This was really cool to like hear from everybody.
Mm-hmm. Yeah,
thanks for sharing.
It was really
Thank
great.
you.
And I think, like you said, you are using it and you're finding the water doesn't have any smell. It's clear coming out of the tank, right?
Mm-hmm.
Yeah, it's probably very high quality water, even without the UV. And you could get that tested, just to have some assurance that it was. Having said that, even testing is your nose is and your sight is the best test of water quality. It's better than labs. You can tell from just looking and smelling at water that it's good, better than you can necessarily with lab results, which is really, really, really interesting. Because labs, a lot of times, the kind of tests you can get on water are only looking for indicators of what might be in the water, right? So that's a whole nother rabbit hole we could go down on why testing is even kind of tricky and people kind of get misled into trusting testing. And Peter says it over and over again. He's a microbiologist. Your best way to know if your water is good is start with a good system. You know, don't do this don't take water out of the creek and do this test. Take water out of a roof harvested system with screens, right? And you take it out of the tap, and if it's clear, there's no sediment, and it smells good, it's very high quality water, with you knowing. And make sure there's no humans on the roof. Make sure there's no cows defecating on the roof, right? There's not. And you can have extremely high confidence that the water is very good quality.
So if I were to look at it under a microscope, would I be able to see like any like aggregates in it, or like what is a normal amount to see like in the water?
That's a really good question. I might have to punt that one to Peter. I mean, you know,
I also have a background in microbiology, so that's why I'm like real nerdy about it.
I know. So do you believe in so, you know, I guess it's the question of like, is biology bad? Is like drinking some microbes harmful to you or not?
That's a good point.
And you know, you can go, let's just think this through in terms of microbes. You could go to Mexico and drink water that doesn't make locals sick because they have the right kind of bacteria in their stomach. But yet you don't have those bacterias, and basically you drink this water and you get the trots. So like, but is it life-threatening? No, maybe you have a little bit of indigestion for a day. It really just is this idea of bacteria, right? You don't have, or it's different bacteria than what you're used to. It's not, yeah, I think the more sterile just maybe a personal perception, but the more sterile we've become, I think maybe the less resilient we're also becoming too. And this idea of everything being totally sterilized and having no life and no bacteria in it. And that's why I send my kids out into the garden. And when they're like, pull a carrot, I'm like, oh man, don't wash it, just eat it. Or, you know, when they come in from playing outside, as long as they were playing in organic soil, I'm like, no way, do not wash your hands. Let's go straight and eat dinner. And there's a great book called The Good Gut, all about that, on how, you know, we've almost become too sterile and to our own health detriment.
I have an image on my roof of a lot of squirrels that are on my roof, and then a lot of birds. And we also have notifications about avian bird flu, which I assume would be a virus and not a bacteria. And viruses are generally like 1 micron. So I'm wondering about all of those problems that could be coming into your rainwater, and what is it about your system that would be clarifying it?
Okay, so first, like the pathogens associated with birds. So 2 is I think it's Campylobacter and Salmonella. They are extremely fragile. So first you have to have a sick bird, and then it has to but that bacteria is also really extremely fragile. So they don't like UV light, they don't like cold, they don't like heat, they don't like dryness. And then the natural treatment train that I described, the combination of screens and your tank bioreactor, and then the pump filter and the pump itself is very, very good at eliminating these fragile bacteria. Never mind that our human systems, like your acids in your mouth, your throat, and your stomach, are also very good at eliminating small numbers of bacteria. So where you might have an issue is if you don't have screens on your tank and you have birds and lizards and frogs living in your tank, like direct access to your water storage, those are the kind of situations where I think you could possibly, if you had a sick frog or a sick bird or a sick possum or a sick squirrel, because only sick squirrels will make you sick, right? And even at that, actually, I should actually back that up. Most pathogens don't transfer very easily from animal species to human species. Like there's very, very, very few pathways that animals make us sick. And the few that are extremely fragile. But yes, keep them out of your tank. Do not let them live in your tank, breed in your tank, defecate directly into your tank, and you're fine. Having said that, when I say fine, would I recommend a rainwater harvesting system for someone who was immunocompromised? You know, if there was somebody who, you know, an elderly person who, or maybe someone who was just sick and immunocompromised, well, then you might go to you might want higher assurances that those kind of things aren't going to be in your water. But a healthy adult can actually handle it. I say this carefully. There's all these, think of that, like you've got all these it's not like the sick bird is defecating on a piece of food you're putting in your mouth, right? Like there's all these interventions. The system functions really well. And when you finally when it goes through the whole system, you can add up the risk or the probability of that bacteria getting to the end point, and it ends up being extremely, extremely low. In fact, lower than being sick from municipal water, lower from the risk of getting sick from municipal water.
Right, so that's bacteria. What about viruses?
Yeah, it's the same. Yeah, it's the same. Viruses. And the biofilms are really good, really, really effective.
Getting close to our time limit here. I see Jackie has one question, or Jacqueline has one more question about open pools of water.
Oh, and just back to the viruses, the microfiltration or the ultrafiltration at your tap is also another really important intervention, right? Like a 2-micron filter is what's going to get rid of any viruses that make it through all those other things. So I'm not saying don't put microfiltration or ultrafiltration at the tap for your drinking water, but you don't need it in your shower water, and you definitely don't need it on your garden water.
Do you see that question in the chat, Michelle?
Where we're considering moving, there's a ton of open tanks, like pools used as water sources. Yeah. Open tanks, like pools used as water sources. Well, I mean, if it's for irrigating lawns, that's fine. I mean, out where I live, people will put in dugouts and then water their cattle, and pump out of the dugouts or creeks to irrigate their gardens. So I definitely don't like the idea of drinking out of open tanks if there's no screens. And it depends on how they're filled, right? Are those tanks filled from creeks? It's totally different than if they're filled from roof catchments.
So I've got one question. Rainwater can be such a valuable resource at both ends of the spectrum, from drought-stricken areas to, last year we saw Hurricane Ida dump inches and inches and inches of rain in the entire state within a matter of hours. Do you have any experience with the latter, with runoff and stormwater management, harvesting specifically for that purpose? I know there are some counties in New Jersey that are now offering tax incentives. I believe Somerset's one of them. If you collect rainwater at your home, you'll get a tax break. Does that exist in the places you've worked? Does it prove effective?
Oh my goodness. Okay.
I know we've got limited time.
I've got time to answer this question, and I want to, if you have time to listen to my answer. It'll take about 10 minutes. Let me pull up a diagram. Okay, I'm going to show you 2 diagrams, 2 really great pictures here. We're going to talk about the system impacts of rainwater harvesting and why a county might want to offer incentives. So just 1 minute here while I open up a couple pictures. So with rainwater and without.
And while you're opening, I'll even just say I would serve to benefit. We had rain coming in during that storm from our door frames, just from the gutters not being able to handle the load. So even just collecting some of that somehow probably could have alleviated that burden.
Okay, so I want to talk about the big picture, the big system impacts of rainwater harvesting at a small household scale, right? So I'll explain this diagram in an instant, or in a few minutes. But to start, you often get this perception that the solution to our big problems, our big city problems, or our big community problems, is to put in a big solution, right? So that, yay, the city is dealing with crazy amounts of stormwater runoff, or maybe they're polluting a river that they pull water out of because of all the stormwater, and they need to solve, the environmental regulations are getting stricter, and so they need to put in a big wastewater treatment plant or something like that, right? So what this diagram is kind of showing is it's a kind of a typical city in anywhere, any developed country, really, where you've got often, cities along these waterways. Here's like a river going out to the ocean, and then they've got a dam where they're pulling water out of the dam for their water supply, right? And then they're distributing that water through this, they treat it, and then they send it to all these different subcatchments. So often these would be different drainage networks. So, you might have a little house. Your little house might be one of these little circles, right? There's all these different catchments. And what happens in a big rain event is this little diagram here is called a hydrograph. And the pink line, ignore the blue, pretend like the blue's not there. The pink line kind of represents what the runoff from like your typical urban plot looks like in a big rain event. So it starts to rain, say the rain is kind of coming across the city. And this is time over intensity, or peak or flow rate, right? So you start off, it just starts to rain, and more water starts running off the roof. And this house doesn't have any rainwater catchment. It doesn't have any catch basins. It doesn't have any mulch basins. They're basically just directing that rain straight from the downspouts to the storm sewer. So the hydrograph at this little house here in this catchment D goes up, it peaks, and then it goes down. And then as you move further down the catchment, you kind of get these two allotments. You have the first property, allotment is Australian word for property, and here's your second property. And then as they combine, you're kind of going down the catchment. Here's the combined peak and the combined hydrograph for all the properties upstream, right? And so you're starting to see these bigger and bigger peaks. And then by the time you get down here to your stormwater management, where the city or the municipality is trying to figure out how are we gonna, how do we treat this? You end up having to design treatment facilities that can manage this very large peak flow rate, because all that matters is peak flow when you're trying to clean up wastewater or stormwater. Your facility needs to be big enough to manage the peaks, even if 99% of the time you don't have peak flow. And this is very, very, very expensive, like $1 billion type infrastructure that cities are needing to upgrade right now or needing to build, right? So what happens when cities get smart and planners start understanding how systems work, they start to realize that rather than spending $1 billion or in the millions of dollars retrofitting improving their stormwater management or building a big wastewater treatment facility down here, they can start encouraging or doing tax incentives or different kinds of planning incentives to encourage people to do things at their property scale, such as like simple things, just improving the carbon content of your soil. So you can do stuff to the soil, planting gardens, right? You can start doing planning differently. So it's not all concrete surfaces, but there's more catch basins, there's more green. You encourage more local retention, which would be a rainwater tank is an example of local retention, right? It rains, but you're holding back that first volume. There's all sorts of things, anything using vegetation, soil profiles, and rainwater harvesting. So now what's shown on this graph up here, the blue represents what a household looks like that has all of the above or any of the above. Like let's just say a rainwater tank. So it starts to rain in the same rain event, but for the first little bit, you're capturing all that rain in tanks or you're holding it back in some sort of a mulch basin, right? And then suddenly you get to the point where your tank's overflowing or your mulch basins are overflowing. And then so your hydrograph jumps up and you kind of return on the same peak. So what gets really neat is when you move further downstream, you have the two allotments that look like this. But the cumulative effects, when you add those two blue together, look at this, your peak has been drastically reduced. And then when you get even further down the catchment and you get to your wastewater, where your stormwater management is right before you discharge back into this creek, by encouraging household action, action at the household scale, you substantially, like it's almost half, reduced your peak volumes at the node, at the spot where you're possibly, looking at treating water or putting water back into the river. And so this cost difference is enormous. And it is really in the millions, if not, I want to say billions, but it's in the millions of dollars. And this is Peter's area of research that he talks a lot, and he works with councils and municipalities to understand what these dollar values are and how to encourage this kind of behavior at the household level. And he's shown over and over again several municipalities in Australia that have started doing incredible tax benefits, even paying people to put in tanks, because they figure it's cheaper to actually help people put in tanks at every single house than it is to design the wastewater facility for this peak versus this peak. So I don't know if that was more than you bargained for, but that's the answer to that question.
No, that was fantastic. Thanks for jumping in deep there. It's just funny how some things are taken by the community. They were calling it a rain tax because the municipality actually had to invest so much more money into their stormwater management that it was going to reflect in tax increases. So to avoid the rain tax, you could assist with the mitigation. But this is a great graph. If you don't mind, can you leave it up for just a second? I'd love to. Do you mind if I grab a screen grab of
No,
that?
you're welcome.
Thank you.
Yeah.
No, that's awesome.
Yeah, and so it does matter. And these little solutions, like what Crops is doing, and when people put rain tanks on their house, it kind of feels like, oh, it doesn't do anything. It's such a small action, but it really does. The impacts are cumulative, and the cumulative impacts are significant. And it's just it's actually a nice place to leave off, in that, like, it does matter and it does make a difference. And starting to harvest rainwater just on your little urban plot or wherever you live is is important and is the positive change we need. And don't downplay it, because it's fantastic and it does great things for your community.
Fantastic. Thank you for such an awesome presentation. Very thorough. I feel like I need to get the book myself. I'm not going to lie. I haven't read the book yet, but
Yeah.
As everyone might have seen in the chat, by participating in the quarterly book club, you've got the option to use the 25% discount for the book. Please buy the book, share it with your friends.
Or check out the online course. The free one is fantastic. And even what I would say about if you really want a deep dive, come join Peter and I in our online courses, because I think even in the 5 years since I wrote that book, there's more updates, there's more changes we've made that we've continued to improve in the science that are reflected in the course. Whereas the challenge with the book is you write it and then you put it out there and you can't do the ongoing edits and updates. So for instance, first flash diverter is an example of that, where I won't put them in my systems anymore. I leave them out. I think they cause more headache than they do better. But the book has pictures with first flash diverters, and I just wish I could send a note out to everybody who has the book. Don't do that.
Awesome. Well, just in case anybody missed any of the things we mentioned or any of the links, I'm going to go ahead and follow up with an email. And so I'd love to get any other links that you might have for us so I can send them to the group tomorrow. But otherwise, Michelle,
Sure.
Thank you so much for joining us. Thank you for bringing all this information and helping us manage our stormwater a little bit more effectively.
Yeah, Deb, and I'll include these two illustrations too, if you'd like. No problem.
Thank you.
Your Dropbox link. All right. Thanks, everybody. Have a great night.